In the last lecture, we walked through how to get census data using the Census Bureau API. But sometimes there's a simpler way to do this, and this is what we're going to focus on in this lecture, using the Senpy package to access census data. And we'll also introduce some basic plotting of geographic data using the really powerful geopandas library. So let's look at an example of Senpy. We can import the products here and create a connection to the American Community Survey. And the Senpy online documentation is very helpful in seeing which functions and attributes are available. So here we can see that there's the ACS, we can look at which variables and tables are used, and we can filter tables. And there's similar interfaces for the 2010 census. We could also call help ACS or just ACS ? Rather than looking at the online web page. So this tables attribute seemed useful. There are also filter tables from county functions, which I want to look a little in more depth. So ACS tables just tells us the names of the tables, and then each table has one or more columns that are available through Senpy. So everything from population, by sex, by age, by race, down to more complex information, for example, on health insurance coverage. So one of the examples that I want to use here is looking at the age of the housing stock. And so to do this, we know that the Census Bureau has a year built field, so which year a housing unit was built. So let's see what tables have that information. Let's get all the tables using this nice filter tables function that have built in their description. So you see there's a bunch of them. Some of them have just one column, some of them have many columns. So everything from the year structure built to median year, 10-year by year structure built, and so on. So if we want the simplest version, it looks like this second one. 25035, it just has one column, the median year, that's going to be the simplest way of looking at this data. And let's see what is here in Riverside County. So I'm going to use this products.acs, the 2017 ACS, and I'm going to use the from county function, which is documented here on their website. So there's some examples, or at least it tells us what type of county, the variables that we want, the level, whether it's tract or some higher level, whether we want to return the geometry, this is going to turn out to be very useful, and some other optional parameters about precision and so on. So I'm going to do this for Riverside County in California. This was a default, I didn't have to specify this, but I'll specify the geographic level for completeness. And I'm going to want this variable, this one that I took from this column here, 25035001E. Takes a while sometimes to query, especially for large counties. We might get a bunch of future warnings. These are often just a warning to the developer that something is going to change in a future version of the package. So we've got this variable called Riverside. Well, what is it? Looks like Senpy gave us a geopandas data frame. So let's look at the first 5 rows. So it's nice, we have the geometry, we have the data here, so it looks like the median year built for this census tract was 1998. And then the text descriptors of the geography, which census tract, which state, which county, and so on. So let's rename this year built column to something more memorable. This is the same rename function as we did before. So we see we've renamed it to the median year built. Everything else is the same. GeoID gives us standard census FIPS code, and this is going to be really useful. This is the standard geographic identifier, and is formatted as a 2-digit state, a 3-digit county. If we're getting data for counties, we just stop there. It will be 06065. 06 is California, 065 is Riverside. But here we're at census tracts, we actually have another 6 digits, which is a 6-digit tract number. And you can read more about the FIPS standard here on this nice policy map, website. If you're not familiar with FIPS codes, that's a great resource to check out. So we saw that we get the boundaries of each census tract as a polygon, which is also going to mean we can plot the data pretty simply. And here I'm just going to use a standard geopandas plotting function, and we're going to tell it to plot the median year built column, and we're going to pre-create an axis object. So import matplotlib, and then we're going to tell it to create this blank figure, and store the figure in fig and the axis object in ax. We're going to tell it what size figure we want. And then I'm going to call this as a geopandas data frame, a plot function. What do I want it to plot? I want it to plot median year built. Which axis do I want to plot it on? The axis I just created. And then there's some keywords for the color map. I want to add a legend and some legend keywords. So here we get a map of the median year built in Riverside County. We can see the older ones, 1940, here in historic downtown, and then more recent suburban development to the south and the east. So this is a good start. It's a quick and dirty look at our data. There's a lot we could do to improve this map, but let's save that for another time. And in general, the best course is to look at the numerous examples for geopandas that you are going to find online. For example, if you want to change the color bar orientation, if you want to use a different color map, there's lots and lots of examples on the web. So where I want to leave you is that for these types of simple queries, Senpy is a really good alternative to the Census Bureau API. And it also provides a handy way to get the geographic boundaries, which make it easy to plot census tract level information, census block group level information, and so on. But it only has a limited range of geographies and datasets. It looks like right now it doesn't have a 2020 census, so for some tasks you may need to use the Census Bureau API instead.